So in this video, we're going to look at how to add fractions. So we're going to look at three different aspects. That's like fractions, unlike fractions, and then the addition of whole numbers and then a fraction. So let's jump right into it. So the first one, we're going to start with the addition of like fractions. When we talk about like fractions, we're looking at fractions with the same denominator. So when you take let's say 30 over 12 plus 17 over 12. Now this is a like fraction because this is the denominators and they are the same. So with this, all that you need to do is to just add the numerators, which is 30 plus 17 all over what, 12. Then when you add 30 plus 17, you get 47 over 12. That becomes the final answer. This is the second example. So we have a simpler question here, which is 6 over 9 plus 3 over 9. Like I said in the first example, all that we need to do is to add the numerators. So when we take 6 plus 3, which is the numerator, we add them. Then we just choose one of the denominator, which is 9. Please, we don't add denominators in the addition of fractions, so never do that. So when we add 6 and 3, we get 9 over 9. Any number over the same number, you just write 1. Any number over the same number, because 9 can go into itself 1 and go here also 1 time. So whenever you have the same fraction of the same numbers, just write 1 as the answer. All right, let's take one last example. So you try this one for me to see. Yes, add the time. Let me see. So 11 over 15 and then plus 12 over 15. Try that. So what we are going to do here is that you're going to add the numerators again. Then we choose one of the denominators. So when you add, you're going to get that's 23 divided by 15. And this cannot be simplified, so you leave it like that. That's all. I think this is clear and you understand. So we're moving on to the next aspect, which is the addition of unlike fractions. So with unlike fractions, we are saying that the denominators are what? Not the same. And we are taking an example. Let's say we have 12 over 3 plus 9 over 4. Now, what you can do is that you find the LCM of the denominators because you want the denominators to be the same so that we can add them. So here, the LCM of 3 and 4 becomes 12. So we take the first fraction, which is 12 on 3. Then we ask ourselves, what number should we multiply by the 3 to give us 12? And in this case, when you multiply 3 by 4, we will get 12. Do the same for the numerator. Then you solve. So 12 times 4, that's 48 over 12. 9 over 4. Ask yourself the same question as you did here. What number should you multiply by 4 to give you 12? Because the LCM is 12, so we want the denominator to become 12. So 4 times 3 gives you 12. Do the same thing for the numerator. 9 times 3 is 27, and 4 times 3 is 12. So all that we need to do is to add these new fractions we've gotten. We need to add them. So we take the 48 over 12, which is equivalent to the 12 over 3. Then we add it to the 27 over 12, which is also equivalent to the 9 over 4. When we add that, we get this and this is 6, 7, that's 70, get 75 over 12. This becomes the answer. 75 over 12 can be simplified because 3 can go into 75 and 3 can go into 12. So 3 will go into 75 25 times and 3 will go into 12. That's 4 times. That is it. So we can even go ahead and decide to leave the answer in mixed fraction because it's not a proper fraction. Just as in the previous ones, so they are not proper fractions. No? In the same way, you can change them to mixed fraction. So we get 6 with number 1 over 4 because 4 can go to 25 6 times. Then there's a remainder of 1 over 4. Depending on the class you are, you can leave the answer either this way or even at this point. That's it. Let's move on to the next question. If you want to try it, all that you need to do is to pause the video and then maybe give it a go. If you're not able to do it, you leave questions in the comment section, something like that. So you're given this question where we have um 1 half plus quarter. That's 1 over 4 plus 1 over 4. 1 over 2 plus 1 over 4. You need to find the LCM. As usual, you need that the LCM is 4. If you know how to find LCM, you can also leave it in the comment section. Maybe you want me to make a video on it for you, I will do that. So let's see. We take 1 over 2 and then we say we need to multiply the denominator by a certain number that will give us 4, and that number is 2. Do the same thing for the numerator. 1 times 2 is 2, 2 times 2 is 4. This is it. Move on to the second one, which is 1 over 4. We need to multiply 1 over 4 by something that will give us 4. And already it is 4, so you don't need to do anything to it, just leave it because it's already 4. The denominator is 4. So we add the 2 over 4, which is the equivalent to the 1 over 2, and then the 1 over 4, which is the same as that. Then we get 3 over 4. And it's a proper fraction, so we don't have to do anything to it. So we have the next question, 6 over 12 plus 11 over 9. We need to find the LCM of the denominators because they are unlike fractions. So the LCM becomes what? Let's find it together. So the multiples of 12 and the multiples of 9. 12 1 is 12, 12 2 is 24, 12 3 is 36, 12 4 is 48, 9 1 9 9 2 18, 9 3 27, 9 4 is 36. So the LCM is 36. So LCM becomes 36 here. Alright, then the next thing that we need to do is to take our first fraction, which is 6 over 12. Then we times the denominator by a number that will give us the 36. So we see that it's 3 times. So we times here by 3 times here by 3. 6 times 3 is 18. 12 times 3 is 36. Now we move on to the next fraction, which is the 11 over 9. We multiply the 9 by a number that will give us the 36 also. So we see that it's 4. So 4 times 4. So we get 44 over what? Same 36. We take the new fractions and we add them. So we're going to have 6 over, sorry. So the 6 over 12 becomes the 18 over 36. Becomes, the 11 over 9 becomes 44 over 36. So if we add it, we get 62 over 36. That is it. But we need to simplify because there's a number that can go into, that is 2 can go here, 3, 2 can go here, 1. So that's 31. Then we have 2 can go here, 2 can go here 1, then 2 can go here 8, 2 8 16. So we have 18. Right, so this is a proper fraction. This is a proper fraction, so we need to change to mixed fraction. 18 can go into 31 one time. Remember 13 divided by 18. So that becomes the answer. Let's go to this one more example, or maybe I will leave the rest for you to try. So let me give you the next examples I intended to do. I will just write the answers. I won't go through the explanation because we have one more part to do, which is the whole number plus a fraction. So I'll just provide the answers, then you try these ones for me. Now the solution to this problem will be 26 over 15. And if you are leaving your answer in mixed fraction, you get one whole number, 11 over 15. So go through the procedure, the steps, and then see if you're going to get the same answer. Now the next one, the solution to this problem will also become that 76 over 45 are going to be the LCM. You will not be able to simplify, so we need to change the answer to mixed fraction. And if we change the answer to mixed fraction, you're going to get one whole number, 31 over 45. That becomes the final answer. So you can leave the answer like this or like that. If you get any of this, then it means that you understand. Now let's move on to the last aspect that I intended to do with you, which is how to add whole numbers and then a fraction. So let's take an example, like maybe you're giving 1 plus 7 over 3. How do you add it? Now you can decide to change this one into mixed fraction. Going to be 2 whole number 1 over 3. That's going to be it. So if you add, you can decide to add the whole numbers and get 1 plus 2, which will give you 3 whole number. Then we just attach the fraction to it and you are done. That's as simple as it. But if you don't want to do it like that, you can do this. So another way of doing it is this. So we have 1 plus 7 over 3. What you do is that you check, because we can only add when the denominators are the same. You can change this to a number where the denominator becomes the same as this. And we have already established that a number with the same number is 1. So you can replace the 1 by 3 over 3, because 3 over 3 is 1. And it will have the same denominator as this. That is why we're using 3 over 3 and not 4 over 4 or 5 over 5 or 6 over 6. Because we want it to have the same denominator as this one, as the other number here, other fraction here. So this is it. So when we get something like this, we can easily add and get 10 over 3, because we said we can only add the numerators. Denominators, you choose one of it. Even if it's 10 of them, you can only choose one. Then 10 over 3 is the answer, or you can change the answer to mixed fraction and get 3 times remainder 1 of 3, like this. Or you can even change to decimal if you want to. So this is the first example. Let's move on to another example. All right, so we have 3 whole number plus 8 over 12. Now this fraction here can be simplified. If you simplify 8 over 12, you're going to get 2 can go here. No, 4. Let's use 4. 4 can go here. 4, 2, 8, and 4, 3, 12. So we get 3 plus 2 on 3. And that answer becomes 3 whole number 2 on 3. So that's it. Or you can just multiply this by that, which is 9. And then you add the 2, which gives you 11 over 3. So either you leave the answer this way or that way. Any of them is correct. But in maths, we normally want to leave the answer either in decimal or in mixed fraction. So this is it. Now, let's look at something now. So how can we solve it in a different way? So if you have 3 plus 8 over 12, because the denominator here is 12, you need to make sure this is also 12. And it's not 1, so we can just write over 12. So what can we do? The 3 is over 1, just as the 1 was over 1. So what you can do is that because we have 3 over 1, we can say, let's multiply this number here by 12 so that the denominator becomes 12. Multiply the numerator also by 12. So we get 3 times 12. 3 12 is 36. And then 1 times 12 is still 12. So we are going to get 36 over 12 plus 8 over 12. I hope you get it. Then we can add the numerators. So this becomes 44 over 12. 44 over 12. Now we have a number that can go into 44 and can also go into, that is 4 itself. 4 can go here 11 times and 4 can go here 3 times. So this becomes the final answer, 11 over 3. But because it's not a proper fraction, it's improper, we need to change to mixed fraction. And we will get 3 whole number 2 and 3. So you realize that this is much easier than this. I mean, I think it depends on you. The one that you feel is easier, you use. Okay, any of them is correct. Let's move on to another example. And like I've been saying, when I put the question down, pause the video, try it out. And if you don't understand something, you can always go back. Just double tap at the back and then just re-watch it. It will help you. So this is our next question: 7 over 5 plus 12. So like we said in the previous example, this solves over 1. Okay, but we're not going to use that example first. We're not going to use that method first. What we're going to do is that we are going to change this one, which is not a proper fraction, to mixed fraction. That is going to give you 1 whole number 2 and 5 plus 12. Then we add the whole numbers. Okay, so we're going to get 1 plus 12, which is going to be 13. Then we add the fraction, which is 2 and 5. And that's simple. That's done. So that's all. That's how to solve it if you want to. But you see that the previous one, it wasn't a mixed fraction, so it was a proper fraction, so we didn't have to change to mixed fraction. Okay, so all that we had to do was just attach the whole number to the fractional parts. And sometimes we just need to simplify before we can just attach them. You can't just do anything. So please keep that in mind. Otherwise, we'd have to go through our long process, which is making them have the same denominator to become a like fraction. So this is 12 over 1. So we need to multiply here by 5 so that the denominators will become the same. So here by 5. So we get 7 over 5 plus 12 times 5 is 60 over, that's 5. We add the numerators, we get 65 over what? 5. And we know that 5 can go into the 65. Sorry, it's supposed to be 67. Sorry. Yes, so 5 can go to 65 13 times. Remainder of 2 over 5. Yes. So that's all. Let's go to the next one. And like I said, please pause the video, try it yourself. That's the only way you will know that you understand it or not. This is going to be my last example. Then maybe I will leave the last one for you to try. I'll give you the answer, but you would have to do it yourself. So this one too, the same thing. We can change the 11 over 4, 11 over 2 to mixed fraction, which is going to give us 5 whole number 1 over 2. So plus 4, which is going to give us, we add the whole numbers. So 5 plus 4 is 9. Then we add the fraction, which is half to it. We are done. But if you don't want that method, you can also decide to use 11 over 2 plus 4. But the 4 is over 1 because it's a whole number. Every whole number has a denominator of 1. So that's just as we've been saying from the, in the previous examples. So we need to multiply here by 2 because the denominator here is 2. So that we can end up getting the same denominator, which is a like fraction for us. So we have here, and this and that gives us 8. This and that gives us 2, right? So when we add, what do we get? This and this gives us 19 over 2. 2 can go into 19. 2 goes into 19 9 times. Remainder of what? 1 over denominator of 2 is the same. This one, if you multiply this by this, 9 times 2 is 18 plus 1 is 19 over 2. So you see that is the same thing as that. So that's how to solve it. Let me give you the last example so that you try it. So the last example that you need to try is 6 plus 4 plus 3 over 2. Okay, so the answer that you're supposed to get is, you're going to get 11 over, no, 11 whole number 1 over 2 is what you're going to get. 11 whole number 1 over 2, or you get 23 over 2. Yes, so if you don't get this, means that the answer is not correct.